Hey guys, so we're moving on to the last set of notes for Unit 8. It's a very short unit, and this is the Day 2 notes, or the 8.2 notes. And this is basically just talking a lot about the independent and dependent events, okay, when we're talking about probabilities. So when you talk about independent events, we'll talk about those ones first. Independent event is when the first event does not affect the second event. So when it's independent, if you think about the word independent, it means that you do it by yourself. So when it's an independent event, it has no effect on the second event that's going to happen after it. So when, for example, a couple examples of independent events are spinning a spinner, that's an independent event, rolling a die, flipping a coin, picking a card, and putting it back before you pick the next card, okay? So those are examples of independent events. So when we are calculating the probability of two events that are independent, this is how we're going to do it. If we're, if we're calculating the probability of two events that are independent of one another, then we are just going to take the probability of those two events and multiply them, okay? We're going to multiply them together. So that means we're going to be multiplying some fractions, okay? So let's look at examples of independent events. So a spinner is an example of an independent event. So a spinner has 10 equally sized sections, 8 of which are gray and 2 of which are blue. The spinner is spun twice. What is the probability that the first spin lands on gray? So that's important to note. The first spin lands on gray, and the probability that the second spin lands on blue. So again, we have to find the probability of both events. So in red, let's calculate what the probability would be for landing on gray. How many of the slices are gray? 8 of the slices are gray out of 10 total slices. And then remember, when they're independent, we're going to multiply them. So we're going to times that by how many of the second spin, how many of the slices are blue? 2 of the slices are blue out of, again, 10 of the total slices on not slices or sections of the spinner. So there's my second fraction. And then we're just going to multiply them. So 8 times 2 is 16. 10 times 10 is 100. And if you divide those both by 4, you should get 4 over 25. Okay? So here's another example of an independent event. A student ran out of time on a multiple choice question. Okay, so a multiple choice question is an independent event. There are 5 answer choices, and they want the probability that she answered neither of the problems correctly. Okay, so if you think about a multiple choice question, there is only one right answer out of the 5 answer choices. So that means that if there's only one right answer, then there are 4 wrong answers. Okay, so they want the probability that she chose neither correct. So you're going to say, okay, the first time she chose an answer, she got it wrong. So that's 4 out of 5 times the second time she chose an answer, she got it wrong. And again, that's 4 out of 5. So then your final answer here, if you multiply the two, would be 16 over 25 for the probability of that she answered neither of them correctly. Okay? So that's independent events. They do not affect one another. Dependent events, the opposite. If you think about what the word dependent means, it means we depend on someone else. So the dependent event is when the first event does affect the second event. So for example, an example of a dependent event would be picking a card up in a deck and not putting it back in before you pick up the next card. So you're picking a card up out of the deck and you're not putting it back in. So that means that the total number, let's say you had I don't know, 10 cards to begin with. That means when we multiply out the second event that happens, we're still going to multiply. We're not putting that card back. So that means my total in the bottom is going to change to 9. That's really what that means. And again, we're still multiplying. So this is how it looks like in probability form. You would say the probability of the first event times the probability of the second given the first. Okay? So let's look at the examples. So in our example, it says there are 8 people fishing. It says 5 have licenses and 3 do not. An inspector chooses 2 of the people at random. What is the probability that both people have licenses? So we're looking for both people to have licenses, okay? So that's two events. So first of all, how many people have a license? 5 of them have a license out of 8. So the probability of picking someone with a license would be 5 out of 8 for the first time. Times the probability of the second event says that you have to pick from the license, but we did not put that person back. So that means there are only now 4 people to pick from with licenses out of only 7 people total to pick from. So my bottom number changed, and so did my top, because this is a dependent event. We are not putting the person back into the pile. So if I multiply those out, I should get 5 times 4 is 20, and 8 times 7 is 56. So my final answer here would be 20 out of 56. Let's try that one again. So this one says, a small class has 9 students, 5 of whom are girls and 4 of whom are boys. The teacher is going to choose 2 of the students at random. What is the probability that this teacher will choose 2 boys? All right, so this time it says, okay, the teacher wants 2 boys during each time that she chooses. So the first time that she chooses a boy, her chances of choosing a boy are 4 boys out of 9 students total. The second time she chooses a boy, now I only have, since I already chose a boy in the first round, I only have 3 boys to choose from out of 8 total people to choose from, right? Because I got rid of the first boy. And then if I multiply those out, I'll get my answer. 4 times 3 is 12, and 9 times 8 is 72. So the probability of choosing 2 boys would be 12 out of 72. Okay? And again, they want that in simplest form, so you would just simplify that. So that's independent and dependent events. Let's look at a couple more examples just so that we can get the extra practice and we can see whether we can notice the independent versus dependent. So in the first one, it says a box contains 5 plain pencils and 7 pens. A second box contains 6 colored pencils and 2 crayons. One item from each box is chosen at random. What is the probability that the plain pencil from the independent box from the first box and a colored pencil from the second box? Well, right off the bat, as I said, I can tell that these are independent events because they are 2 separate boxes, right? We're not picking from the same box. We're picking from 2 separate boxes. So that tells me I'm going to do independent events here. So if I look at the first one, it says we want the probability that a plain pencil is picked from the first box. So there are 5 plain pencils in the first box out of 12 pencils and pens in the first box. So I would say 5 out of 12. And the second one, they want a colored pencil from the second box selected. So I'm going to multiply this times a colored pencil. There are 6 colored pencils in the second box out of 8 total out of 8 total colored pencils and crayons. So there are my 2 fractions, and I'm just going to multiply them. So if I multiply them out, I get, I can actually reduce before if I wanted to. So first of all, I know that 6 can be divided by 6 and it's 1, and 12 can be divided by 6 and it's 2. And then, now that I have it kind of semi-reduced, there's nothing else that I can do here, then I can just multiply across and I'll have my reduced fraction. So 5 times 1 is 5 over 8 times 2, which is 16. So our final answer here would be 5 over 16. And again, this is something that you can have the calculator help you with. It's just something that you might notice. If we look at the next one, it says a disc jockey has 7 songs on his upcoming playlist. 3 are rock, 2 are reggae, and 2 are country. Chooses the first song to play and then chooses a second song from the remaining ones. So keyword here is from the remaining ones. That tells me that this must be an example of a dependent event because we're only choosing from the ones that are left. Okay? So let's look at what they want. They want the probability that the first song is a reggae. So let's make that fraction. So there are 2 reggae songs out of 7 total to pick. So it would be 2 out of 7 times. They want the probability that the second one is a rock song. So again, there are 3 rock songs to choose from, But I don't want to choose that first song that I picked, so I only have 6 songs remaining. There's the dependent events. And then if I finish this off, I have 2 times 3 is 6, 7 times 6 is 42, and you can divide those both by 2. So it becomes 3. Actually, I'm pretty sure you can divide those both by 6, right? So if you divide those both by 6, instead, you're going to go get, let me erase that, you're going to get 1 out of 7, 1/7. So your final answer here would be 1/7. All right, and then you have a radio disc jockey again down below, so I won't do that one, but let's do the math class with 5 girls and 5 boys. So a math class has 2 grade levels. It has 5 girls, 5 boys in 7th, and 3 girls and 7 boys in 8th. Teacher randomly selects a 7th grader and an 8th grader from a class for a competition. So that tells you that these are independent events because they're from two separate classrooms, okay? So what is the probability that she selects both girls? Okay, so first of all, in 7th grade, how many girls are there in 7th grade? There are 5 out of 10 total kids in 7th grade. Times, the second one is how many girls are in the 8th grade? There are 3 out of total people in the 8th grade is 10. Okay, now that I have my 2 fractions, I can multiply. So 5 times 3 is 15. 10 times 10 is 100. You can at least divide these both by 5. If I divide them both by 5, I've got 3 out of 20. There's my final answer. Okay, so take your time with these and really think about independent versus dependent events. And as always, let me know if you have any questions. Good luck.